Okay, I'm gonna give you one more shot here, and then I'm gonna let you get after these. Number 5 is a tough little problem. You know, when they have those little dark black arrows, that means parallel, and we know that parallel leads us to congruent angles. I marked the congruent angles on that diagram because of the, like, this would be the transversal, and therefore those would be corresponding, and same with the others. Well, all that allows me to realize is that by angle, there's two triangles here that are similar, and so the smaller triangle MLP is similar to the larger triangle MKB. And I just mentioned that here. I made a note of it so I'd know where the corresponding angles and sides are. And then I did my little trick where I pulled them out and made two separate triangles, because to me, I just can't make sense of all this. This one's a little bit step harder because it has the X's in there, and so I just do the exact same process though. I wrote X plus 9 over here because this is X and that's 9, and so X plus 9 would give me that whole length. X was the one over there. This was 16. 24, I had to get 24 by adding 8 and 16 for the larger one. But once I write it on my two separate triangles, then it becomes clear that X is to X plus 9 as 16 is to 24. So I set my proportion up. Well, when I set the proportion up, you know, because of the fact that there's X and there's an X plus 9, I have to cross multiply just like I would. I multiply, you know, what do I do when there's X's on both? So I just cross multiply, and when I'm done cross multiplying, then I'm through with the proportion. That gives me an equation to solve, and so there's a distributive property that I have to process through here, and so here's my steps on solving for X. And so that problem's a little bit more difficult, a little bit more going on, but this is real common for similar triangle type problems that our publisher will throw at us. So I think you got this. Give it a shot.